Graphene. In its two-dimensional form, graphene is thought to be the strongest of all known materials. But translating that two-dimensional strength into useful three-dimensional materials has posed quite the challenge to researchers for decades. But now, a team of MIT engineers has successfully designed a new 3D material with 5% the density of steel and 10 times the strength, making it one of the strongest, lightweight materials known. And by analyzing the material's behavior down to the level of individual atoms, they were also able to produce a mathematical framework that can accurately predict experimental results. To test their material, the researchers printed 3D models made purely of commercial plastic and subjected them to various compression tests to see how much they could handle before the structure begins to crumble. Here, we see two 3D gyroid models made from the same exact material. Their only difference is one is composed of thicker walls than the other. Once stress is applied, we almost immediately notice two very different reactions. The model composed of thinner, more flexible walls enabled it to fail gradually upon increasing deformation, while the other, with thicker, stiffer walls, is able to store much more deformation energy, which is then released in a more severe, explosion-like manner. Ultimately, their new findings show that the crucial aspect of the new 3D forms has more to do with their unusual geometrical configuration than with the material itself, which suggests that similar strong, lightweight materials could be made from a variety of materials with similar geometric features. Having the ability to tune the mechanics of a material by simply adjusting its geometry opens the door to a wide variety of practical applications, including strong, lightweight structural materials for airplanes, cars, buildings, and other large-scale applications. Because of their continuous porous geometry and large surface area, they could also have applications for filtration and energy storage.
Characteristic of bat flight, I have teamed up with my colleagues at the University of Illinois Urbana-Champaign, Professor Seth Hutchinson and Dr. Alireza Ramijani. We have created Batbot B2, a fully self-contained autonomous flying robot that weighs 93 grams, to mimic such morphological properties of bat wings. We implement highly stretchable silicon-based membrane wing that are controlled at a reduced number of dominant wing joints to best match characteristics of bat flight. The continuous surface and elastic properties of bat skin are realized with a custom-made ultra-thin 56 microns membrane wings. Our Batbot B2 has onboard computer and several sensors for performing autonomous flight control and navigation in its environment. The brushless DC motor drives a crankshaft mechanism. A sophisticated inertial measurement unit, or IMU, measures angular rate and acceleration. Data acquisition unit records sensor data and commands the micro actuators. So we have 5 magnetic encoders located at the elbows, hip joints, and shoulder joints to read the relative angles between the limbs with respect to the body. Each wing actuator, which is composed of a planetary gearhead, a spindle drive, and DC gear motor, produces the required linear motion. We have identified 5 dominant motions of the bat flight and implemented those into the design of B2. In an indoor environment, B2 robot has successfully performed straight flight up to 30 meters. The main wing of the B2 is supported by 2 independent wing folding joints. B2 performs turning maneuver by independently controlling the folding motions of the left and the right wing. B2's tail legs can be controlled independently. Sharp diving maneuver performed by bats when they pursue their prey was reconstructed by moving the hind limbs or legs.
Hi Kickstarter, I'm John, an industrial designer with over 20 years experience designing and developing products for industrial clients. Fabricating models and prototypes is a huge part of what I do, whether I'm using a laser cutter, a CNC router, or a 3D printer, or all of them together. But of all the methods and tools that I use, there's one I've relied on heavily over the years, and that's vacuum forming. It's my so-called secret sauce when it comes to making three-dimensional plastic parts. The problem is though, Vacuum formers aren't exactly accessible. They're massive, factory-grade equipment that costs an arm and a leg, and there aren't really any proper desktop versions of them either. Until now. This is VacuForm, the world's first digital desktop vacuum former. Now everyone can shape and form plastic like a seasoned pro, with VacuForm's smart, efficient, and easy-to-use features, such as the exclusively designed high-performance hybrid vacuum system that delivers extremely detailed shapes and parts, a computer-controlled heater and thermal probe that monitors a plastic's temperature in real time, and a built-in library of heating profiles for various materials, so you're sure to get perfect results part after part after part. Just select the correct profile from the menu, press start, and wait for the vacuum to switch on. Once it's on, all you have to do is lower the handlebar and begin vacuum forming. With a vacuum form, you get a compact professional-grade vacuum former without a hefty price tag, allowing you to finally get that ball rolling on that business idea of yours. Or simply make things for your own personal enjoyment, whatever those things might be, whether it's one of designer toys, custom packaging for bespoke gadgets, or one-of-a-kind art pieces. By backing my project, I'll be able to produce the first batch of vacuum forms and put them in the hands of makers everywhere, helping them bring their awesome ideas to life. I'll also be able to do further research on new raw materials and develop VacuForm software even more, continuously expanding its library of heating profiles. So VacuForm actually gets better with time. Now that sounds like a pretty good investment, don't you think? For more details, feel free to look around my Kickstarter profile and make sure to visit VacuForm's official website and Facebook page. Thanks. Now let's get ready to vacuum.
I see smog and pollution every morning.
You can see it on buildings.
Air pollution is killing about
tiny particulate matter in the air reach nearly under.
It's really hard to get fresh air.
I used to think the sheer scale of this issue can make us feel powerless. But when you connect ideas with passion and creativity, amazing things are possible.
Hi, my name is Anita Sharma and I'm the co-founder of Gravity Labs. We are an MIT spin-off which works on building technologies that can make a real-world impact. We built this contraption that we connect behind the exhaust and the tailpipe of the car. After we're done capturing the raw carbon, the soot, we take it through a purification process and then we convert that air pollution into printing ink. The same technology can be scaled to fit onto boats, chimneys and brick kilns, and cranes. But hey, we've captured all this air pollution inside this little bottle. And now you can paint with this.
So we've transformed air pollution into 150 liters of Tiger Air ink.
Now it's time to pack our bags and take this technology out of the lab and test it for the real world. Putting this ink in the hands of people who are actually going to use them.
What an amazing city. I need to write about this place.
Did you ever miss a flash of creative genius? Well, you're definitely not alone.
I need to bring Jessica here. She would love this place. I have to share that with everybody.
We are building a first smart voice recording wearable. It's handy and allows you to capture your thoughts with a quick motion. Nothing to distract so you can stay focused on what really matters to you. Organize your notes with hashtags and integrate them with your favorite apps. You can create voice memos, lists, and send reminders to your colleagues. our device has some amazing features. It removes noise and runs it through our own AI system for noise pattern identification. Take notes and capture your greatest ideas with ease when you're out for a walk or run. It works offline just fine, so don't worry about leaving your phone at home. A full battery charge lasts for about 4 days of average use. Sandstone has futuristic design to make it memorable and you remarkable. It's created in the intersection of waves and symbolizes the sound that you create when you speak. It fully charges in 30 minutes on a specially designed dock station that can fit the device in all of your interchangeable bags.
With all the distractions and life on the go, it's so easy to forget a great idea. Sandstone is a notepad built for your busy everyday life.